All right, guys, welcome back to another episode of Within Tolerance. This is episode 41, and we are joined with Drew from Drewfab. Make sure you check his Instagram out. We'll be tagging him in our Instagram post along within the podcast description. But without further ado, Drew, just tell us kind of how did you get started into this world of manufacturing? Tell us your backstory. Go back as far as you want to. Give us any cool stories along the way, and the floor is yours.
Cool. Well, thanks for having me, guys. I really appreciate it. It's pretty cool. So about 29 years ago, I was 8 pounds, 7 ounces. No, I'm just kidding. When I growing up, I pretty much always was super into cars. My dad's been racing and building cars and hot rods for, I don't know, his whole life. I'm like third generation hot rodder, right? And so it kind of started there. Started racing. I got a junior dragster when I was like 8 years old, so I started racing that. Everything's pretty much motivated and centered around either going fast or a car or something with wheels or horsepower, right? So the joke is if it's got tits or tires, I can make it squeal. So, but
so and it'll cause you problems, right?
Yeah, right. Yeah, exactly. They're both expensive. Just kind of got started down that path because of my dad. He's not a fabricator, a machinist, or anything like that. He's actually terrible. It terrifies me when he picks up a grinder or a welder. But he's a really, really good mechanic. And so he taught me how to work on stuff, how to put things together, how to take them apart. Kind of one of those typical rebuilt my first engine, like lawnmower engine at like 6 years old kind of thing, right? So that's kind of where it all began. And he and I have always worked really closely together, and he was a big motivating factor there. So kind of fast forward a few years going into high school, I told him that I wanted to build a hot rod. And so that's when we bought, he actually traded. So my dad owns a vending machine company, little side note. He traded an old junk piece of crap vending machine that didn't work for a 1972 Ford F100 that didn't run either. Right. So we spent the next 4 years restoring it, and it was my hot rod that I drove around and whatnot. And kind of got to the point. So this is, Payton, a little before your time. Sorry, Dylan, you'll sympathize here. Is during the American Chopper, American Hot Rod era.
Oh yeah,
right. So I was heavy into like Monster Garage. I mean, Jesse James was my idol when I was a kid. And I still, the guy is super talented and definitely is inspiring from a talent perspective, and seems like he really is a genuine guy. So
yeah, it's coming back too. I'm pumped.
Absolutely, it's amazing what he's doing. Some of the stuff he's doing, right? Total inspiration. Yeah. So watching him and the American Chopper guys, do their thing, and I was like, man, I want to be a fabricator. That's what I want to do. I want to weld and cut tubing and make badass stuff, all day long. I want to learn how to TIG weld and lay dimes, right? So I don't know, I was 18 or 19 when I got a MIG welder and a chop saw and a tubing bender for Christmas, right? And so that kind of started me down that fabrication road. And then I started college. I went to San Diego State University. And while my first month in college, I got a buddy who does radiator work. They do exhaust and radiators. And I walked into his shop and he TIG welds, and I was like, dude, teach me how to TIG weld. And so I started working with him. He taught me how to TIG weld, and ended up working for him in the shop for about, I don't know, maybe a year and a half, 2 years, somewhere in that ballpark. And he taught me how to MIG weld. Really refined my ability to MIG weld. Because when you're welding exhaust and stuff, it's more critical. It's thin stuff. Taught me how to TIG weld. I mean, the very first thing I learned how to TIG weld on was 50,000 stick aluminum, which is like everybody's terrifying, factor. Like they see aluminum, they go, oh my God, I can't do it. Right. And it was on a Miller dial arc HF, like circa 1975, a white face dial arc HF. Which is not they say high frequency, right? HF, it means high frequency. It was 60 hertz. That was high frequency back then.
Holy crap.
So, and that's a sine wave machine. So there was no like fanciness, right?
Right. No square wave, no adjusting your arc, nothing. Yeah.
None of that. The only thing we didn't even have post flow adjustment on this machine. So there was no really refining any of it. And if you could weld on that machine, you could weld on pretty much anything. So I worked, like I said, for about a year and a half, and then he turned me on to a buddy of his who's got a fab shop building off-road race cars. So in San Diego, right? San Diego is off-road mecca. From my house, within about a 6 mile radius, there's like 14 off-road fab shops. And I worked at most of them in one capacity or another, whether it was for CAD or whatever. Right. So, I kind of went over to his shop. This was Kurt, became a really good friend of mine. And he taught me how to fabricate. He really taught me how to build a roll cage, how to design suspension, how to, do all this stuff. He was building trophy trucks and things like that at the time. And worked for him for a little bit. And then I don't know if you guys have ever heard of Cheneth Racing. They were kind of big back in the 70s and 80s, did a lot of government stuff. That brand got sold off, and I ended up doing some other stuff with them through Kurt and some other folks. And just kind of bounced around a couple different shops, including Stewart's Raceworks, which was actually my first real kind of CAD job. I walked into a shop one day, and I just finished my ME 101, which is your SolidWorks and Pro Engineer class at San Diego State. And I was like, dude, I just want to be here. You don't need to pay me. I just want to be here. Right. And because they build pre-runners and truggies and things like that. And I walked in there and it was like a tear came to my eye. They got freaking synchro waves and dynasties and tubing benders and fixture plates and a CNC brake and a plasma cutter and a water jet and like just fabrication equipment galore, right? Nothing I've ever really seen before. And so I worked for him for about 6 months doing CAD work, 6 months to a year doing CAD work and whatnot. And actually, if you guys Google him or YouTube him, they built the very first Ford Raptor pre-runner. They took, I don't even remember if it was a Raptor body. I think it was just an F-150 body. But in any case, it was a quote unquote Raptor pre-runner, full tube chassis, luxury pre-runner, badass thing. I helped them do some of the CAD work on it. I didn't do a lot of it, but I did some of it, just kind of verifying dimensions on stuff. And so it kind of just led me down this kind of engineering and fabrication rabbit hole, so to speak. And then I got hooked up with the Formula SAE guys and the Baja SAE guys at San Diego State. At this point, I was a mechanical engineering student, which didn't last actually. And I got hooked up with the Formula SAE and Baja SAE guys as a fabricator, basically. And that kind of morphed and grew into I was lead fabricator and lead chassis lead on the Formula team 1 year. And then also I was lead engineer kind of sort of on the Baja team for a couple years. And about my sophomore year, I changed from engineering to physics. So my degree is actually in physics. And my emphasis is actually in optics. So I learned all about lasers and light and things like that all through college, which really does not translate at all to manufacturing. I get that question all the time. How do you get in manufacturing? So around the same time, right, my sophomore year in college, I realized that fabrication kind of sucks. I mean, it's super fun to build something, but it's also a nightmare, and you can't make any money doing it. And then the next kind of logical thing was machining. And so there was 2 machine shops on campus. One was in the engineering department, and then one was in the physics department. Nobody knew about the one in the physics department. It was in the basement of the building. One guy ran it, old grumpy bastard, super cool dude. I mean, really, really good machinist and a really, really fun guy to be around. But like I'd walk in the shop and he'd go, "Oh man, I was having a good day too." Like just that kind of old school grumpy guy, right?
Ugh.
But he was really, really fun to work with. Once you got past that, if that didn't turn you off, which it didn't for me because I'm a pain in the ass, it was actually really fun. He was super cool. I learned a ton from him. So I decided to work for him for a while. I did a quote unquote apprenticeship. So I worked for him for about 2 years and most of it was, turning little stuff on his engine lathe or, decking off parts or, cutting stuff to size before it went on the CNC mill or sawing stuff or tapping holes, the typical grunt work, right? Sweeping floors, shit like that. But I did learn a lot from him. And in that same kind of time period, I started buying my own equipment. So I've actually bought that dial-arc HF from the guy that I learned on. I bought my first MIG welder. My first real MIG welder, I should say, not a Harbor Freight one. I bought a little better tubing bender, and then kind of started doing my own side work while I was going to school. Because I figured if I'm going to be doing something, I might as well be making beer money. so this whole thing kind of culminated when I graduated college. I graduated with a degree in physics with about 2 years of a machinist apprenticeship, which is enough to be dangerous, right?
Oh yeah.
That's about it. And then my junior year in college, so I actually did 5 years, so I'm calling it my junior, but it was actually my fourth year in college. My buddy and I got a contract from a guy to build this race truck. I was like, cool, score, right? And he had a shop that we could use. So we filled the shop with all of my crap. I built a 4 foot by 10 foot fixture table that I still have. Brought the TIG welder up there, got a new tubing bender that was a much nicer one, things like all sorts of stuff. Bought a lathe, a manual lathe, bought a manual mill, and just kind of retrofitted this shop to build this truck. Well, about 4 months into that, we're gung ho. His dad got cancer. He's okay. His dad's actually still with us, but his dad got cancer, so he sold everything off. And so then I'm like, okay, I got this mill and this lathe and all these other things that now I don't know what the hell to do with. So I stuffed it in the one car side of my parents' garage. And that's where my quote unquote business, before it was really a business, started. It was in my parents' one car garage. So kind of circling back, when I graduated college, I had this equipment. I had a degree in physics, and I had about 2 years of a machinist apprenticeship. And I'd actually been welding and fabricating for almost 4 years, might have been closer to 4.5, but somewhere in that ballpark. While I was in college, my senior year, I got an internship at Solar Turbines, which is where I work today, as a manufacturing engineer. And the guy saw my resume and was just, he saw, several jobs working for people in the fabrication industry, and and then the machining apprenticeship, and the job doing CAD and all this kind of stuff, and just was all about me working there. So I did an internship for a summer there, and then after the internship, they offered me a job to come back after graduation, and I did a rotational program. So the way that Solar's rotation program works is you get about a year and a half to go through 4 to 5 different business units, and you get to see a whole bunch of stuff, which is really cool, because Solar, we make, contrary to a lot of what people think, because Solar, it's a very deceiving name, we make industrial gas turbines and we make gas compressors. So our primary customers are oil and gas.
Do you make anything solar at all?
No, not at all. So there's a whole long story with that, but essentially our turbines are named after constellations: Centaur, Taurus, Titan, things like that. So that's where the Solar name comes from.
Gotcha.
In a nutshell, that's not the whole story, but in a nutshell, it's not because we make solar powered turbines, which is what I get all the time when I do these not trade shows, but the things for kids to come give you their resume out of college and stuff like that. They always say, "Oh, you guys make solar powered turbines, right?" No, we don't.
Well, and that doesn't make any sense anyway. I mean,
no, it doesn't.
Yeah,
it doesn't.
Oh man, that is funny.
Yeah, so I got in this rotation program, and I did my year and a half, and I got stuck in the I say stuck, but it was actually where I wanted to go, in the development department. So I was in the heart of our development manufacturing, where we develop our combustion systems, our fuel systems, things like that, which is really cool, really neat stuff. And we got our own machine shop that we staff and make all these development parts, these R&D parts. So I finished that up, and that rotation, which put me back in that R&D group. And then the guy that ran the R&D group called me into his office. This was like January. I'd been back to work for like 2 days after Christmas. And he calls me in his office. He's like, "Hey, I have this group down in Mexico, and I want you to go run it." I'm like, okay, am I going to get, killed on the other side of the border? Like, am I all right? Or, and and he's like, no, it's legit. You're good. So Solar also has a facility. We have 2 in San Diego, and then we have 1 in Tijuana, Mexico. So I actually worked down in Mexico for about a year with another guy who was a machinist, one of our master machinists, which is the guys in the R&D shop, and learned a ton from him. We actually taught this group of interns, is actually what they were, a machining class, and I taught them how to use lathes and whatnot, because what we were doing was we were training them to become CNC programmers and and manufacturing engineers, it was weird being a 1 year basically manufacturing engineer going in and now training other manufacturing engineers and CNC programmers and being like, I don't know what I'm doing. How am I supposed to teach them what they're doing? Right. So did that for about a year. And then he called me into his office again. He goes, so I got this new additive manufacturing group that I'm starting up. I'm like, okay, we need an ME. I'm like, yeah, sign me up for that. I want to do that. That sounds like fun. Because when I first started at Solar, they had just brought in their first Lulzbot TAS 3 or 4 or whatever the hell it was. We had just kind of gotten into that desktop 3D printing stuff. This was 2014. So we just kind of gotten into that. And then by the time I was done with all this 2.5 years later, we had just set our first metal 3D printer on the ground. We had a few more desktop. We had like 6 desktop 3D printers. And we were buying a Stratasys PolyJet 3D printer, plastic 3D printer. And so they needed somebody to do the manufacturing engineering. And you might, most people, when they think of metal 3D printing, they think, okay, why do you need a manufacturing engineer? You just print the part and it's done. But it's not that simple.
Geez, not at all.
And I've fought that battle for years. So I want to actually take a step back. I want to talk about my side business just a little bit before I get into the solar stuff, because I think the printing deserves some time. But I also want to talk about how this kind of all ties together with my side business, right?
Yeah,
so,
totally.
The side business is kind of chugging along. I'm doing fab work, little odd jobs, $100 here, $200 there, $300 there, kind of thing, right? Making bumpers and roll cages. And I got my niche in Jeeps, so I started making roll cages pretty much exclusively for Jeeps. And the claim to fame was that the way I design the cages and the way I put them in the Jeeps, I don't weld them, or I don't bolt them to the floors. If I do bolt them in, it's got a strut going to the frame, but most of them are welded to the frame because I'm working on usually older stuff, the CJ series. And the claim to fame is that I can get you more legroom, which, as stupid as that sounds, when you're talking a CJ7, they have the clutch, on the left side with where it should be, and then they also have the e-brake right next to it. Most bolt-in or cages that people make, they put the tube, the A-pillar tube for the roll cage, right in front of the e-brake. So you get a roll cage, but you get no e-brake.
Oh, geez.
You literally can't get your foot in there. So I figured out a way to make the cage wider, and it actually requires notching like 1/4 of an inch of material out of the rocker panel. And then you can still tie it into the frame and everything underneath. So it makes them really strong and really stout, and really safe. But then you get the stupid e-brake back. It just it's the simplest little details, right? And so I started kind of doing that stuff, and then it went into suspension work and things like that. I started tuning leaf spring suspensions for people on the Jeeps, and then got into some more, 4-links and coilovers. And then I built a Jeep for a guy, I don't know, maybe 5 or 6 years ago now. And it was featured on the cover of JP Magazine. It's a red CJ7, and it's really, really cool. We did everything. I back halved it, did the 4-link front and rear coilovers, whole 9 yards. I mean, the thing is truly a really nice piece. And that kind of got the ball rolling for the business to actually become kind of a legitimized business, and started doing more of the roll cages and other stuff for other people. And then it started becoming more like manufacturing when I kind of decided that machining was a good thing to do, right? I started making parts on my manual mill, which it's really precise. It can hold about 10 thou on a good day. If you treat it really nice, it can give you a 256 surface finish. It's pretty sweet. My manual mill. It's better. It's a tube notcher and a drill press, quite frankly. That's all it's good for. Yeah, that's all it's good for. So, and then I started kind of doing this machine work, and I realized, okay, I need a better machine. And so about 3 years ago now, I bought the CNC mill that I have today. And the reason I bought it was because it had no electronics, and I got a good deal on it. And I paid $2,500 for basically the iron, and it was in really pretty good shape considering what it was. It'd been sitting for like 25 years probably, and it had one of those old Bandit controls on it. I don't know if you guys have ever seen those things. It's like a 1-line NC control, and totally useless. You can't even make them work if you wanted to. One of the machines, like Dylan, you were talking about, that had glitches. Old machines have glitches. These ones were prone to glitch.
Yikes.
And so it's a Shizuoka. I'm not sure how you pronounce it, but it's a really stout machine. It's got boxways. It's got ball screws that came with it from the factory. Really, really heavy duty. It's like 6,500 pounds. It's really heavy for what it is. It's got like 18 inches of wide travel and like 36 inches, I think, maybe 31, something like that, X travel. The only real limiting factor on it is it's got only 6 inches of quill Z travel, but the quill's like 5.25 inches in diameter. It's got a 40 taper. It's a pretty beefy machine for what it is. And so I started down the DIY rabbit hole, right? I bought motors and drivers and stuff from China and retrofitted this thing. I ended up doing a Masso CNC and started getting work. As janky and horrible as the machine looked, because it looked like kind of a tweaker experiment, it made okay parts, and I started doing work. And I've always had some designs for some of my own parts. The 4-link tabs were the first thing I made. I don't know if you guys have seen those, but they're on my website and whatnot. And that was like the first quote unquote product that I really started making was the 4-link tab.
Those were what you were cutting with that end mill you were experimenting, right?
Yeah. So that Destiny tool that I tried out, that was what I was cutting with them. And those were a special configuration for a special request for another customer. But yeah, that's what I was making.
Okay.
So those were the first thing, like I said, the first product that I started making. And I got an order for 24 of them. And I made like 3, and the machine, the electronics totally took a shit. Like it was just done. It scrapped like 4 parts in a row, but by just glitching, and like the whole be off center 50 thou. I'm like, what in the hell? Like what's going on? And it wasn't exactly a good setup. I had chain drive gear reductions on the motors to the screws. It had, it was just not an ideal situation. The max rapid was like 50 inches a minute. It couldn't move very fast. And so then I was like, okay, I got to do something, but I need to deliver these parts. So I got a friend that has a machine shop in town, called him. I was like, hey, can you make me 24 of these? And I paid him, delivered the part, or got the parts and delivered them to the customer. But then that started me down looking for a retrofit. This is why I have a Mock Motion retrofit, and this may sound sales pitchy, but it's not. They did not pay me to say this. They're not paying me to do anything right now. Yeah, seriously. I've been talking to them, but they're not paying me right now.
Not yet.
Not yet. Hopefully. But I literally just started Googling, right? And so, Centroid CNC and all those kinds of things come up. You see, and then Track. I started talking to Track, and that was a nightmare. They were kind of a nightmare to deal with. And I Googled controller or retrofits, and Mock Motion was like the second hit. And I filled out like 4 forms on like Contact Us. I had a phone call from Mock Motion literally probably 5 minutes after I filled out the form.
Wow.
It was just immediate. And it was Matt Sands, I believe is his last name. Super nice guy. Started talking to him. We talked for like an hour. And I was like, yep, this is what we're doing. And it was about 10 grand, all said and done. I had a couple of extra little bells and whistles. I got the like wireless pendant and stuff like that. And they shipped it to me. It was just bitchin' packaging, and everything was just perfect. And I put the thing together. It came with plates to adapt the motors to my machine. I mean, just everything was right on the money, right? Put the thing together and dialed it all in and set it all up, and then got it running. And the machine's not perfect. The screws have about 1 thou and 1/10 in backlash, so it's not great. It's not horrible, but not great. But it does pretty good, and I make it do things it should never have done. So that's what I've been using to make these parts. All this, like the sway bar arms, all that stuff. That's what you're seeing. I mean, that's what they're getting made on is this machine. And so I'm making this old ass machine do things that it was really never intended to do. But I've kind of learned how to massage it and make it do what I need it to do. You don't interpolate critical things, basically, is what it boils down to. So back to kind of the 3D printing stuff. Sorry for the little tangent there, but back to the 3D printing stuff, back to solar. So, like I said, we bought our first metal 3D printer in like 2014 or 15. And that was a 3D Systems Pro X300, and which is best used as a boat anchor. If you have one, I'm sorry. There's a reason there's a reason they're discontinued, and 3D Systems will tell you that too.
Oh wow.
And it was super cool. Like the ability to come up with an idea and design it and then print it and have it in like 4 days is just mind boggling to me. We have a little Prusa here at the house. I was telling my wife, was like, I was able to design this thing, 3D print it, and have it in like 6 hours, and then iterate it and print it again, and then have another one the next day. I'm like, do you understand how mind blowing that is? Like, just it's totally mind blowing to me. I still love it. I have a passion for 3D printing.
Yeah, it's awesome. That's
It
really cool.
really is. It's not the end all be all. It's not gonna take our jobs. I know everybody talks about that, but you can't have 3D printing without manufacturing and machining. So it's a
Right.
manufacturing process, much the same way a CNC machine is a manufacturing process.
Yeah, we use them at work. I use them to make CMM fixtures, and like I'll
Yeah,
always have the guys there. They're like, "Oh, well, how long did that take to print?" I'm like, "Oh, it took 8 hours, but I started it when I left for the day, and I came back to a finished
right,
part." Like
right. Yeah,
it's
you said
it
you guys have a
takes its
form too,
time.
right?
Yeah, we have a farm too.
Nice. Yeah, that's a good little machine.
Yeah, it's not too bad.
No, not at all.
But so, what do you guys use? You have all these metal printers and plastic printers. Like I can understand using metal printers. I've heard of like GE using metal printers to try to print parts for flight and things like that. And I understand using metal printers for possibly gas turbine parts that aren't, I don't know, don't need to be forged or anything like that. But what are you guys using plastic printers then? Just iterative design?
So we use them for a few different things. Tooling is huge, right? So and when I say tooling, I mean like fixturing and things like that, right? Not consumable stuff. And so our tool group makes huge use of the polyjet for that primarily. So a lot of gas turbine parts, like pretty much everything in the hot section of the turbine is has to be flowed or flow qualified, and so that requires typically some sort of like gasket material to seal it to the flow bench. And so we 3D print a lot of plastic parts with rubber, and the harder plastic is one piece. That's what the PolyJet's really good for. Is it can do rubber, which is I think Agilis, and then the digital ABS kind of as one part. And then you can actually grate the durometer too. So you can actually functionally grate your material to have a different durometer in a different area or a different height or whatever. You can actually set the durometer of the rubber too within a range, of course. So that's one of the biggest things we use it for. We also do a lot because everything, like I said, is flow qualified. So when you're talking a combustion system of a turbine, you have to have certain airflows through the turbine, through the fuel system or the combustion chamber, and those like the fuel nozzles, that kind of stuff. And so that's how we kind of set all of our fuel injectors and our combustion liners and things like that. And so in order to get kind of a first crack at it, because you have a design and CAD never matches reality, what we do a lot of the time is we'll 3D print them in plastic, that same part. We'll measure it, make sure it's correct, or at least to size, and then we'll flow it. Because what we can do, like our Form 2, we were able to print like 14 fuel nozzles that are 14 different sizes and configurations and flow them all. And then we were like, okay, these 3 are the ones we want to go to metal with. And so we do a lot of that kind of stuff too. And then obviously like little odds and ends. You'd be surprised all the little detail kind of stuff that you can print that would be useful. That if you had to make it out of metal conventionally, it would just be a nightmare, right? So does that kind of answer your question? That's kind of the biggest things, like 2 or 3 biggest things we use the plastic stuff for.
Yeah, no, that totally answers it, and that's what I love to hear because that's what I constantly am telling people about 3D
Right.
printers is like, it's not going to take our job away, but it'll make our job. It means that I won't be making 5 useless prototypes that the engineer is going to throw away in the end anyway. Like,
Exactly.
and
Exactly.
that's what I like. Or I'm not going to get the call halfway through, op two, like, oh, actually,
Yeah.
I need to change this and this and this. I've just figured it out. It's like, man, if only you had 3D printed it earlier and just figured this out before you wasted all of our time and money involved.
Right. Yeah. That 1/4 inch hole. Can you make that 240? Like, no.
Right.
No.
Yeah. Yeah. There's no moron tool.
Yeah, exactly. The thing that I still want to try, we've talked about it, is you couldn't use it for heavy cutting or anything like that. Is 3D printed soft jaws, because if you could 3D print something with enough oomph to be able to withstand some sort of cutting force, you could potentially cut down your time. Like you could plan 3 or 4 days ahead, on your job, print those jaws, slap them in, and yeah, maybe you're just doing a couple holes or something simple. But it's not something that you're going to do high precision work, and you're not going to take big cuts. But it's something that me and a guy at work have been like, man, I want to try it just to see if you could do it.
Oh yeah, I think you totally could.
I
I
think
know
so.
that there's people with the Markforged printers that have
Yep.
done that.
Yep. The only thing that I think the shortcoming you'd have with the plastic is the surface impact resistance, I guess you could call it, because it's just not as hard as like an aluminum or something like that.
Yeah, no, I think you're right. You'd be limited to like side holes or things
Right.
where you're drilling and the forces are really low. But even then, I mean, if you could save making soft jaws for 2 or 3 side ops, that would be
Right.
heaps better.
Or if it's something complicated too, you have a complicated shape to hang on to. Something weird that's easier just to pull the CAD out and print it. That'd be where I think that's where it would shine.
Oh yeah, for sure.
So, Drew,
Yeah.
what kind of metals do you actually print these parts in?
So I can't give you too much detail, but what I can tell you is we print you're talking the metals you said, right?
Yeah.
We print in nickel alloys as well as stainless is what we do.
Okay.
And so it's funny, Dylan, you were talking about, if it doesn't need to be forged or whatever. We've actually found that a lot of times, yeah, your part may not quite be as good as a wrought forged product, but it's better than investment casting, which the gas turbine and automotive industries are built around investment casting, which is like your lost wax, right?
Oh, wow,
And
okay.
so our parts, at least, I can't speak for everybody, but our parts in general are stronger than an investment casting, but just barely shy of a forging, right? So it's actually usually pretty good. It's a very different microstructure that you get out of the 3D printing versus a forging or a casting process. However, it is a very strong part. It's not like people think of you're getting, styrofoam kind of material quality. It's a very dense part. Our parts are our spec is between 99.5 and 90 and 100% dense, fully dense. So we don't even
Whoa,
accept anything if it's less than 99.5% dense,
Wow.
which
that's
is better
crazy.
than a lot of bar, right?
Yeah, totally. That's insane. Yeah, I had always heard that with the metal 3D printer. This was years ago that I heard it, but that like there's infinitely more data available currently for like titanium and nickel based alloys and stainless steels than there is like aluminum. And so like
Yeah.
it's the exact opposite of machining where like aluminum is the real pain in the ass to print and something like titanium is like, oh yeah, we've done that since the inception of these machines.
Well, yeah, I mean, titanium is used in the medical industry, right? And so that they started using that in the RCAM, which is e-beam machines, and that was where that got its start. But aluminum and titanium both actually are challenging because they explode. That's the biggest thing.
Oh right.
They,
Yeah.
yeah, you have to build a bomb-proof room around the machine.
Yikes.
Yeah, it's kind of
Jeez.
scary. So one of the things I think would be good to kind of like touch on for people that are listening is, 3D printing is thrown around, and I think when you say 3D printing, everybody thinks of like a Prusa, your desktop 3D printer, or maybe someone thinks of a Formlabs or whatever, something like that. But in reality, there are so many different types of 3D printing modalities, is what they call it. Sorry to sound corporate, but you have metal 3D printing is not limited to laser powder bed fusion, which is what we have. So laser powder bed fusion is you lay down a layer of powder, right? And you melt it with a laser. It's actually called selective laser melting, is what the technical term is. You also have electron beam, same thing, but with electron beam instead of a laser. And that's actually done always in a vacuum because of the way the electron beam interaction with the air is really kind of interesting. But then you also have binder jet, right? So you lay down binder on powder and then you sinter it. Another totally different way of doing it. There's dozens of ways to make both metals and plastics. And one of my favorite things to tell people about is the sand molding. So there's a company called X1, and they make 3D printers that print sand for sand casting. So if you're making something that's not super high volume, like you're making onesie twosies, or you're making maybe 10 of them or something like that, X1 will print you a sand mold and core, and all you have to do is deliver it to a foundry. In a lot of cases, the foundries actually have them now, and they'll pour your material, and then you have a sand casted part. It's a one-time use thing, but if you don't have to buy the tooling and pay pay for a pattern maker and all that kind of stuff, it could be really beneficial.
Yeah, they had one of those companies at AU 2 years ago when I went. It
Oh,
was
really?
it was insane some of their demo parts. I was like, this is nuts. I mean, yeah, because now that I work with a lot of castings at my day job, I've seen, how costly some of that can be, like the tooling and all that. And so to see
Absolutely.
how relatively cheap they can make these really complex parts was really, really amazing.
Well, I think the biggest thing, like you touched on, is the iteration time, right? You could feasibly make 2 or 3 casting iterations, which would never be feasible before.
Oh yeah. Yeah. And you realize things like when you're dealing with castings that you're like, oh shoot, I wish I had, taken away 10 thou on this surface or added
Right.
20 thou on this surface because really I needed 20 thou to clean it up,
Right.
and like to modify that tooling is always so expensive that, yeah, if you could take that part out, it'd be amazing.
Yeah, absolutely. Absolutely. Yeah.
So
And go
you
ahead.
touched
Sorry.
on it a little bit. What's the difference between an electron beam and a laser? Like what are the advantages? Why would you choose one machine versus the other?
So, electron beam welding, or I'm sorry, printing it's a very different process from the laser. So the machine itself is in a vacuum. You put the build chambers in a vacuum, so it takes time to like pump it down, things like that. So that's one major cost. You have a vacuum pump, which you don't have with most. I don't even think there is a laser system. I don't quote me on that. I don't know for sure, but you don't have that with the laser systems. So that's one major cost. The surface roughness on an electron beam is significantly rougher, um, and the depowdering time is usually a lot longer than your typical laser system. It's a more costly process. It's not necessarily better or worse, but it is more costly. It's very widely used in the medical industry because it's very highly controllable with the oxygen content, because you're in zero atmosphere, right? It's all vacuum. So I know Stryker Medical, I think, is one company I heard talk at one of the conferences. They use RCAM e-beam machines for their hip implants. They make the hip implants. That's one of the things you might use it for. One of the kind of interesting things about e-beam is the support structures, because the build chamber is also heated, which is not typical of most of the laser systems. The support structures are very different, and you can actually kind of free print and powder a little bit differently than you can in laser systems. So just there's some different characteristics of it. The biggest thing is the surface roughness. The thing that you would see the most, I guess, is the surface roughness is way worse. And so you're not really getting a net part. You're getting a truly near net part, and you're going to have to machine it.
So are they cheaper machines then? I mean, I know you said the vacuum pump obviously is a more expensive process, but like it sounds like there's nothing but drawbacks with that process. So I just don't see why anybody would choose it over a laser machine.
Right. So one of the things that you can do with it that you can't do, or I guess the laser is lagging, is some of the alloys. So because some of the alloys are very sensitive to different heat inputs and things like that, and I'm not a metallurgist, so I'm not going to be able to give you the exact information. But I know we've worked. That's why we've used it, is for certain alloy development, and then also certain geometries too. You can't print those geometries on a laser system. So like Stryker, I believe they free print their hip implant, the cup, and it has this like lattice structure on the outside of it. It was really cool. And they were able to do this specifically on an RCAM machine out of Tie 64, which I think it was Tie 64, might have been something else, but I think it was 64, and which they couldn't do on a laser system. So there are parts that you can make on an RCAM or e-beam system that you just can't make on a laser system, and vice versa.
Okay, that makes more sense.
Yeah.
Gotcha.
So
So, Drew, I'm curious, with your background of learning about, like you said, optics and lasers and light and all that, I'm curious, does that help you at all? Understanding how some of these printers work, or at least in the beginning. I mean, it sounds like you've got it figured out now, but does that play any role with your kind of day-to-day job?
no, I wish.
Yeah.
The thing it does, like you said, Peyton, it gives you kind of a fundamental understanding, right? You just
Yeah.
kind of, I think the one thing engineering in general, like the fundamental of engineering, is it gives you the gut feeling of what is the right thing to do, I guess, if you want to put it that way, right?
Okay.
So it's kind of the same thing with that. Like, I don't necessarily need to know all the inner workings of the laser to be able to work on the machine. But it helps with some problem solving stuff here and there, like diagnosing issues. And then we've had some weird process drift here and there, and we just knowing the inner workings of the laser kind of helps you diagnose that kind of stuff.
Okay, makes sense.
But day to day, no, I don't use it hardly at all, which kind of sucks. But it is what it is.
Sounds cool though.
Yeah. Yeah.
Yeah, you can at least pretend you know. I mean,
Yeah, I mean, I used to be able to tell you all about helium neon lasers and all sorts of cool stuff, but you start throwing out like laser modes and things like that, and people are like, "What are you talking about?"
so I guess what else would you want? Somebody listening. What do you think are like the biggest misconceptions? You've kind of touched on a few of them, but like if you had to set the record straight for 3D printing, what are the things do you want to share with our audience? I guess that would let them know what's up.
So I would say the couple of things that are really important is if you're a machinist, don't worry, you're not going to lose your job. That's a huge deal. 99% of the time, it has to be machined. Period. There are some cases when it doesn't. We have one part that we actually cut off of the build plate and then put it in service. We don't machine it, but that's not the norm. That is very, very seldom. The other is just what I just said, cutting off the build plate. Most people don't realize the parts are actually welded to the build plate that they're built on in the machine. Everybody thinks of like their plastic 3D printer where you just kind of break them off or whatever. They actually have to be physically cut. So we wire EDM all of our parts off of our build plates.
Oh, that's crazy.
That's cool.
Yeah. It's pretty neat. It's amazing. You kind of use a wire EDM like a bandsaw, which is kind of a shame.
The hot spot for metal.
Yeah. The other biggest thing with 3D printed parts, and I would say the biggest challenge, is work holding, because it's kind of like a casting, but it's also not, right? Castings, you expect them to be kind of crappy as far as like dimensional and things like that. And most of the time you're removing enough material so where it really doesn't matter. But the 3D printed parts, it's quote unquote near net. So you're leaving 50 thousandths on a surface, or you're leaving whatever on a surface just to clean it up. You're usually just cleaning them up. And so what we've found is parts are never round, parts are never square, surfaces are never flat. And the surface roughness is bad enough to where you can't really use it to, I guess, you can't use an AM as printed surface to pick something up directly. So like Payton, when you do get a probe, you're not going to probe off of a 3D printed surface.
You can't just say that like that.
Oh, smooth.
You're not going to just probe a 3D printed surface. You're going to you have to put like a parallel or something up against it, which is like your GD&T basics, right? And then probe off of that datum simulator, right? That's the way you're gonna be able to pick up that surface. And then the last thing is you cannot take an existing design. I don't care what anyone tells you. You cannot take an existing design and just 3D print it. It just doesn't work. We've done it numerous times. There might be like, if you're making a block, you're making a cube, fine. Yeah, whatever. But like if you're making anything with any kind of real complexity, it's you have to design it for additive. You can't just print it. That's just a super common misconception. Oh, we'll just print it. No, you have to design it for overhangs and support structures. We spend so much time and money designing parts to be able to be printable, because the more support that you have to remove is wasted money. It's like chips, right? When you're machining, you try to minimize your stock and all that kind of stuff. Same concept. But the difference is this stuff is really hard to remove because it's oddball shapes. It's like the support structures, if it's non-solid, things like that. It's it's all handwork. It's an ergo issue. It's a safety issue. You got powder trapped in parts and things like that. So you have to design the part specifically for additive manufacturing. People do get away with just printing parts, but it's not the solution. The best bang for the buck is like, we have a part, I can't tell you what it is, but it was a combination of 43 parts into one.
Ooh,
Wow.
and
that's
it
crazy.
removed like 6 braze cycles. So we do furnace brazing. I don't know if you guys are familiar with furnace brazing,
Mm-mm.
but we do nickel alloy base furnace brazing, and it removed like 6 braze cycles. It removed, like I said, the 43 components and like 3 sub assemblies. So
Wow.
that's where you get your bang for the buck. Is combining components, designing it for specifically for additive manufacturing, and tailoring the design specifically to what you're trying to do.
So you talked about machining these AM parts. I have heard in the past, I don't know if it's still true, that there are like some crazy internal stresses on AM parts.
Yeah, it depends, right? It depends on a lot of things. We were talking about design for additive. So part of designing for additive is also keeping in mind the stresses, because so with 3D printing, it's all about heat management. Everything is heat management. So if you want to think about it, you have kind of a couple things to keep in mind. One is localized heat, right? One is the heat of a layer. Uh, the next is the heat differential layer to layer. And then also on top of that, then you have the heat of each part. If you have multiple parts on a build, the heat of each part. So the heat of the whole build plate, right? So what you are trying to do is minimize the delta, the change in heat, layer to layer, part to part, feature to feature. The more you can minimize that delta, that change, the less you're going to have, less stress you're going to have in the part. We've actually seen parts with like line defects in them from just a cross-sectional area change layer to layer over the course of like 10 layers. And it caused so much stress, it'll actually cause the part to deform. Um, so when you're talking about like stresses, that's one of the things we do is we look at that layer to layer and part to part and feature to feature relationship from a heat perspective to try and keep the change in heat from all of those things to a minimum. Because the more you can keep it relatively, I would say, smooth from a transition standpoint with no spikes one way or the other, then it's going to not actually have a lot of stresses built up in it. The plate does, because the plate's getting, it's getting welded on one side and it's not on the other side. So it's going to warp, but that's normal. But in general, our parts are round. And so when you're talking round parts, they don't really potato chip too much.
So, the like you're talking about design guidelines to prevent this kind of stuff. Is this all just knowledge you've gained from screwing up, or do you have specific software that helps you follow these design guidelines, or do you have internal documents that you guys follow? Like, where does this is this just tribal knowledge that you guys have come across, or like
Right. Yeah, for the most part, it's tribal knowledge. So we've tried like NetFab and ANSYS and some of the others that have their simulation, and we've never really had a lot of success. As much as I would love to be able to use NetFab and like use their simulation and their distortion module, be awesome. It's not really practical. What we found out from a real manufacturing standpoint, we actually try to do as little as possible with the STL, and so we just go basically straight from CAD to the minimum, convert it to an STL, put it in the build file, and print it. We'll even model our supports and everything in it. So all of that knowledge of supports and overhangs, and just that, like you said, the geometry of how to do it is more tribal knowledge for us. We have documented some stuff, but a lot of it's tribal knowledge.
okay, that's too bad that some of the softwares out there aren't a little easier to
Yeah,
implement that.
it's just mathematically, it's an astronomical problem, right? You have so many variables, and like when you're talking about literally on the microscopic scale, right? So like, I don't know if you guys are familiar with powder size distributions, or PSDs is what everybody calls it. Or particle size distribution, I should say. The powder, you have a particle size distribution, and ours is, I don't know, it's like, I won't tell you the exact numbers, but it's like 20 to 40 microns or whatever, something like that. It's not that, but something like that. So you're talking about particles that are 40 microns in diameter or 30 microns in diameter, and you're talking about a laser beam that has a spot size of like 4,000s.
Oh wow,
You're
wow.
talking very, very small stuff. So you have like powder fluidity. You have there's a really cool video going around of when the laser hits the powder, it actually like creates this plume. It almost looks like the old pictures of the atomic bomb going off. It creates this like plume of powder flying up in the air from the energy release.
No way.
Yeah, it's really, really cool. You should, if I find it, I'll send it to you guys. But yeah, Google like 3D printing, laser 3D printing powder something. Like it's something. If you Google it, you'll find it. It's out there. But it's really, really neat. But like I said, it's on this like micro scale. So when you're talking about all those kinds of things, you have this laser metal, laser powder, I should say, interaction, laser metal interaction. Actually solid metal. You have liquid metal fluidity, you have powder fluidity, you have the powder flowability from a recoating perspective. Then you have, like I said, the thermal management of not only each individual like laser trace, but the scan strategy, how you trace that, the actual tool path itself, then the intra-layer, and then how that interacts with the build plate, your build plate of different thicknesses, all those kinds of things play a role. And there's like a million knobs you can turn on the laser too, as far as power and travel speed and starts and stops and overlaps and everything. I mean, there's so many different things you can tweak that's why the simulation's not there yet, is because how do you predict all that? How do you factor 50 or 60 variables and predict all that?
Yeah, that makes sense. So do the materials at least come from the manufacturer with recommended speeds and feeds, I guess, or power and speed, or what?
Yeah, sometimes like we've gotten stuff. So our newest machines are Concept Laser, which is GE, and they will send us with parameters, and 9 times out of 10 they suck. We make all of our own parameters, but we're a big company. So we're a subsidiary of Caterpillar. So I mean, Cat's got 100,000 employees. We have 10,000 employees worldwide. So we're not a small company. We're a big player, and so we have a full metallurgical staff, or metallographic staff. We have metallurgists on staff. We have material scientists. I mean, we got guys with PhDs that all they do is study metals and materials, right? Full material scientist type deal. So we use those guys and our welding engineers that are on the team to develop and design parameters specific to materials and parts.
Wow, that's awesome.
Yeah, it's really cool.
So, Drew, I had a question for you. Speaking of materials, so for example, for people listening, and I honestly don't know, if you were to print, I don't know, out of stainless steel, let's say something the size of an iPhone, how much would that actually cost in the material itself?
So the material itself is pretty cheap in general,
okay.
Right? So I think stainless 316 from any given supplier, depending on who it is like 20, I'd say relatively cheap, like $20 a pound. So that's not really that expensive, but the machine to print it on is $500,000 or better.
I was about to say, yeah.
Right. And then it requires argon and a ton of electricity. So basically the rule of thumb, if is a build plate, any given build plate, and if it's really, really short, like a really tiny part, this doesn't apply. Or if it's a really, really big part, this doesn't apply. But if you're printing it on the average 3D printer, like your Concept Laser M2, your Pro X300, your DMP 320, any of the kind of average size, that like 10 by 10 by 12 kind of size range, it's going to be like $3,500 or better.
Wow.
Yeah, it's not cheap by any means. But in the case of some of our parts, we put 40 parts on a build plate. And the part that it was replacing was $300 a part. Just the material alone was $75 for a little like slug. So that's where the benefit is.
Totally. So to kind of shift gears here, let's go back and talk about your business.
Okay.
What's next for your business? So we've kind of talked off air a little bit about maybe another machine, or where do you see Drewfab going from here?
So one of these days I need to figure out how to actually be good at what I do. Like you said it, you say it so eloquently, Dylan. The trade honestly never ceases to slap you down when you think you got it figured out. So the way I've kind of always structured Drewfab is I have four segments of the business, right? Or services, I guess you could say. I have the fabrication, which is just welding and fabrication. We do stainless and aluminum welding, things like that, steel, whatever. Machining, right? So that's relatively new. Engineering and like CAD design work. And then now is 3D printing as well. So I offer plastic 3D printing as a service. So for the next step to me is like we've talked about a little bit off air is a machine. I waffle back and forth. Like I talked about, my machine is so, I guess I make it do things it has no business doing, but it is working and it's doing what I need it to do. The next machine I think that makes the most sense for us is a lathe. We've been talking a lot about it. I had a line on one just before the COVID-19 thing hit, and that kind of threw a monkey wrench and everything. So we decided to not pull the trigger on that one. But I think that's probably the next spindle we'll add is a CNC lathe. It won't be some amazing fancy thing, and it may be used. It might be new. I'm not entirely sure. But that's likely what we'll add next. So we'll see. The thing that I want to do. So we launched a catalog of products back in February 21st, which is actually my birthday. We go to this swap meet every year. It was the last one this year, unfortunately, but we've been going to the swap meet for like 20 years. And we had a booth set up. This is the first time we really did this as a business and launched a full product line. So we make shackles for Jeeps, or anything with a leaf spring, I should say. The 4-link tabs. We make some really cool little shock tabs. The sway bar arms. Some tubing couplers that are really neat if you're doing some bolt together roll cage work. Couple little plastic things that we're 3D printing. Camera mount, fit your GoPros and things like that. Little odds and ends. But we spent a lot of time launching this whole catalog of parts, which is a nightmare. I think Payton, I reached out to you, I don't know, like almost a year ago, probably, asking about how you manage stock and whatnot.
Was that really a year ago?
I don't know. It was a long time ago. Maybe it was only like 6-8 months ago. It was a long time ago. Let's put it that way. And that was why, is because we were getting ready to launch this product line. And so the thing for the next step really is to get this product line off the ground. Right now, the business is 80 to 90% job shop, whether that's fabrication or machining, and like 20% sales. I haven't sold a lot of parts, unfortunately. And I think most of that is now due to circumstance. And then my ability to keep up with production in some cases too. I mean, I'm only one guy with one machine, and I do this on the side.
Right. But, and you real job.
Yeah, exactly. Right.
That's hard. I know your pains for sure.
Yeah, exactly. And I like to see my wife too. So, I don't work till midnight every night. So really the next phase is to try and get the product line really off the ground. We've spent a lot of time and money on the website and things like that. We're putting a real heavy focus on marketing and getting our name out there. I think some of the stuff we offer is unique. I think it's good quality stuff. It offers something that's not there in the market right now. It kind of fills a void in the market. It's not overly expensive, but it's also not made in China cheap either. And I'm never going to outsource it. I'm never going to send it to China. I'm never going to make it anywhere but here. So that's one of the biggest things. And then from an equipment standpoint, like I said, adding a spindle, probably a lathe within the next 6 to 9 months, I would hope.
Awesome. Well, yeah, I'm looking at your website right now. Your website looks great. So
thank you.
Doing a great job, getting it out there.
Oh, I'm not doing any of that. Don't believe me. I don't touch the website. My cousin is I joke, he's my IT manager. He legitimately, he's an IT guy in his day job, and he's absolutely amazing. And then my wife does all the Instagram stuff. And by the way, congratulations on being the Machinist Therapy Hotline barbecue vest winner.
Oh yeah, I saw that and I was like, I don't know if this is a blessing or a curse, but
it's both. It's totally both. I was like, holy crap, we're getting the vest. What?
Yeah.
But yeah, congratulations on that. That was your comment made me actually legitimately laugh, and I was like, okay, that was cool.
I saw it and I was like, I don't even know if I really want it, but I gotta comment this. Like,
Absolutely. So, and my wife does all the marketing and the social media stuff. She helps me out with that a lot. That's why the pictures actually look like an ogre didn't take them, because that's the way they'd look if I took them.
Yeah, your pictures are actually awesome because when I'm making the like little collage for every episode on our Instagram, I'm always like, oh, I gotta find some good pictures. And yours, it was like I can grab like the first 8 and like I'm good. Like
Yeah.
this was easy.
Yeah, she does a good job. She does a really good job with it. I think it's made a huge difference. It's helped take the marketing side of things, the I guess you can say the showmanship of what I do to the next level. Because I've always felt like I do something good and do something unique and whatnot, but it's just if you can't show anybody, that doesn't do you any good.
Totally.
Very
Yeah. So
true.
and I guess that kind of we had a few listener questions, and I guess that kind of answers Jake's question of who really calls the shot, you or Sarah, huh?
Oh yeah, well any married man knows that his wife calls the shots. That's just part for the course. I mean, I've been married for 6 months, and I know for a fact that my wife is the one that runs the show.
Oh yeah. And then I guess another question related to this discussion. Nick 523 Industries asked, "What did the barbecue vest smell like when you opened the box?"
Um,
And I
Lost
saw
hopes and
your
dreams.
unboxing, so you know
Yeah,
you had a mask on at one point, and
yeah. Lost hopes and dreams. Sweaty man. Things like that.
and then the last question we had was actually from Jody, and it was more serious. It was if you could only use one machine for the rest of your life, which one would it be and why?
Oh crap. Um, if I had to use one machine, is this one machine period, or like is this specific to machine shop?
It just
That
says one
changes.
machine, so up to you how you want to interpret it. We can circle back around too if you want to think on it.
Um, yeah, let me think about that one for a minute because that's kind of tough.
I know. I read it and I was like, "Ooh, I'm glad I'm not the one answering that."
Yeah, because we use machines for everything. Like our phone is technically a machine, right?
Right. All right.
Oh, I
Yeah.
didn't
I
think
mean, I
about
guess
that.
we'll keep it manufacturing related. So if you had
Okay.
one manufacturing or fabrication tool to use for the rest of your life and only one, what would it be?
I think I would choose a CNC mill personally.
Okay.
Yeah.
Anything specific? Any dream machines that you would
Um,
lay on yourself on the line as your one machine for the rest of your life?
Something with a probe, probably.
Oh, I was waiting for that.
um,
Uh,
um, Actually, if I had to pick a dream machine, that's kind of tough. It'd be between I can't remember the number off the top of my head. There's a Makino 5-axis that's a fairly small package deal that's really cool. Okuma makes a really small little 5-axis that's really cool. I don't remember the number of it either, though, or the name, whatever you want to call it. And then Mazak I100S would probably be up there too. Those are pretty sweet.
oh yeah, definitely.
I mean, that's if I actually had money,
Right.
which I
All right.
don't.
No, that's money and no option. Yeah, I got
Yeah,
you.
right. But I think from an actual practical standpoint, I think a robo drill would be up high on the list, or like what you've got the Speedio. Those I think are I love the capability of those very small compact machines.
Yeah, I'm a big fan. I mean, obviously, I put my money where my mouth was. I
Yep.
was telling people for years that that's what I wanted and that's what
Yep.
they should buy, and I even convinced a few people to buy them. And so, I obviously had to put my money where my mouth was.
Right. Right. Well, and I like what Payton's got too, the DM series. I think that's a good solid machine. It's just I think it's more of a matter of preference and space and what you can afford. Quite honestly.
Yeah.
Totally. So, which one of your products do you need a lathe for, or are you planning on adding more products to your line?
So I have more products I'm going to add. The product that we have made, I actually had someone make me the first run of them, and I believe it's on the website. I'd have to double check that. Is the tubing coupler. So the tubing coupler is an assembly of 3 components that are all turned. One of them, actually 2 of them, I should say, require either live tooling on the lathe or a post processing on a mill, second op. And then basically the way that whole thing works is, have you guys ever done any roll cage work? So do you have any kind of reference of what I'm talking about?
I've seen roll cages made. A good
Okay.
Yeah.
customer and friend of ours, they do professional welding and
Okay.
fab for, like the mirror lab and things like that. So
Okay.
I've seen them do a lot of that stuff.
All right. So, I mean, if you do a bolt together roll cage, there's tubing couplers that you need to put the thing together, right? And there's off the shelf ones that you can buy, and most of them have this like tongue and groove setup where they come together and you have a cross bolt or two cross bolts to hold them together. And they're an absolute bastard to use. I mean, they are so bad because, like anything, once you weld it, it warps, right? And try lining up threads after you've taken this thing apart and powder coated it or painted it after you've welded on it, and try and put the thing back together. It's an absolute nightmare. So I designed this tubing coupler to utilize the concept of a machine taper. So it's a 45-degree taper, and it's two conical components that fit together. And then there's a bolt that runs down the center that's a tie bolt that sucks the whole assembly together. The one that we've released is 1.75 inches in diameter, and it allows you to attach a tube at a 90-degree angle to another tube. And I made a little tool that you use to drill a hole through the tube that's on center line of the tube. And then you drop this whole assembly in there and then weld it to the tube, and it allows you to unbolt it. There's a video on my Instagram that shows me taking apart a roll cage, or maybe putting it together. I think putting it together, a roll cage on a Toyota pickup. So this was the product, or I'm sorry, the project that spawned the product, right? This guy needed a bolt together roll cage on this Toyota pickup, and it needed to have couplers because of being bolt together, and they all needed to be easily accessible. It needed to look clean, and it needed to be easy to take apart and put together. And I hated using the other style, and so I racked my brain, and this is what I came up with. And I was able to put this cage together, and it had, I think, 16 of them in it, 16 couplers, so 16 joints. And I was able to put it together by myself in, like, I don't know, 15 minutes.
Oh, wow.
It's it's a 8-point cage. So it's not like just a 4-point, drop together deal. It's a substantial cage.
Oh, this is the exo cage you're talking about?
Yeah. So if you're
Okay.
looking at an exo cage in a white Toyota pickup, I don't remember where it is, but it is on the Instagram somewhere.
Yeah. I'm going back through your stuff and looking at it. It looks
Yeah.
pretty sweet too.
Yeah. I'm almost certain the coupler is on the site, and there's a cross section view of it. It's kind of hard to wrap your brain around if you've never used them. But once, like, I've shown a couple of guys in the fab world that that do roll cages and whatever, and they're like, oh, I can know like 4 places I can use that right now. Like I can buy 10 of those. I'm like, well, then buy them. That'd be great.
Buy me out of stock. Exactly.
Absolutely.
That's awesome.
Yeah. Thank you. I appreciate it.
Yeah, that's that. I've like I've said, I haven't made one myself yet, but I've seen enough go together that they, no matter how you do them, they're a pain in the ass. But especially couplers. So.
Yep. Yeah, and I want to make the other sizes too, from 1 inch all the way up to 2 inch. But I with having to outsource it right now, I'm trying to keep all of my products reasonably priced. And like the sway bar arms as an example, those are $450 or so retail for a pair. Your average sway bar arm is the pair of them is going to run you like $500-600. And so I'm trying to keep everything priced for someone like me, right? Someone that's wants good quality hardware, but doesn't want to go break the bank and really doesn't need it, right? They're not racing. They're not, I race, but I do drag racing. But if you're talking off-road parts as an example, they don't need the highest end stuff. They're not trophy truck racing in Baja. They're just having fun, but they want good quality stuff. They don't want Chinese made crap, So that's kind of the market that I'm going for. And I think that's where my stuff fits because it's reasonably priced.
Yeah, totally. I think that's really commendable too.
Thank you.
It seems like, especially in racing, and if you're a car guy, you definitely know the pain of like trying to find parts that A, don't break the bank, but B, aren't Chinese crap, and like that's.
Yep.
It seems like those are the two sides of the coin 90% of the time. I know I go through that with my cars too, and bikes and all that stuff.
Yep.
So
yeah, it sounds like you're in a really good spot.
Thank you. Yeah, I think so. It's just, I think most of it's marketing, and it's going to be one of those things where it's going to take a long time. I don't expect to be making $1 million on selling 4-link tabs. I don't make enough money on them. It's not, the goal isn't to make a ton of money. It's to make good quality products at a reasonable price and help people build their own stuff.
Totally. Yeah, that's awesome. That is really, really cool.
Thank you.
Well, Payton, if you didn't have anything else, I mean, we don't want to take up too much of your time, but
No,
if there's
I'm good.
Yeah.
well, if there's anything else you wanted to, share with our audience before we, close, any final remarks, and if not, definitely plug all your social and plug your website and all your
Sure.
parts and stuff like that.
Yeah. So if anyone that's listening did happen to see our website like a week ago, someone hacked my GoDaddy and took the site down. I don't know where they redirected it to. I assume something sketchy. So I apologize for that. It is back up and running now. With the Google ban has been lifted. Yeah. And the website is www.drewbuilt.com. Drew like Drew Barrymore, and I never lived that one down. And built is spelled the way it's supposed to be, Built. And then the Instagram is at Drewfab. The Facebook is at Drewfab. And if you have an affinity for drag racing, you can find our drag racing page on Facebook is Dominique Racing.
Oh, awesome. Okay.
Yeah.
Well, again, thank you so much for coming on.
Yeah.
I know I learned a ton. Like, I've always been super interested in metal 3D printing and never met anybody that could articulate, actually uses it. Like, I've talked to plenty of guys at IMTS and all of that about it.
Yeah.
But, they're only going to tell you that their machine is the absolute best and everything else is crap. And
Absolutely.
so it's really cool to get to talk to somebody who uses one day in and day out and actually gets to, play around with that kind of stuff and use those parts, and in addition to another small shop owner. So thanks again for coming on and sharing all your experience.
Yeah, I appreciate it. Thanks for having me, and thanks for listening to my ramblings.
Oh no, it's our pleasure. All right, guys. Well, thanks again, and we will see you next week for Payton and I.